Hello, everyone. My name is Karanjot Jaswal. I'm the CTO and co-founder at Cinchy. We're a data fabric company, and the name Cinchy is a play on the word cinch, which means simple. There's recently been a lot of hype around data fabrics, but there's also a lot of confusion. Today, I'll be covering some of the core concepts behind a data fabric, where it fits into your architecture to realize the most value, and how it can help to accelerate the projects you already have planned. Let's start with a problem that a data fabric solves. Integration burns half of your IT budget. Prior to Cinchy, my background was in financial services, working at large global banks delivering technology solutions. This problem was one of my greatest frustrations. The root of the issue lies in how we architect solutions. We build technology in the form of applications, and each one of these applications manages data in its own application-specific database. In essence, each application is a data silo and the root cause of data fragmentation. To pull our data back together again, whether it's for use within other applications or for enabling reporting, analytics, machine learning, really anything meaningful that you need to do, you perform integration. And that is the single greatest bottleneck in your IT organization's ability to deliver change. The elimination of integration is our vision at Cinchy, and it's the primary driver behind a data fabric. Imagine being able to double your IT capacity without adding resources. That is the level of impact that this paradigm can have. You may have heard the phrase, data is the new oil. Well, that's not entirely true. It is intelligence that we're after. And when I say intelligence, I don't mean insights. This is not the result of analytics applied to data. Instead, it's the capability of an enterprise to acquire and apply knowledge. Data is certainly a foundation for that, but it's not the full picture. Insights get you up to the acquire knowledge part, but applying that knowledge, evolving the organization's capabilities to take advantage of that knowledge, is incredibly slow. If you contrast that to the human brain and its ability to absorb and apply knowledge, a human's ability to adapt is exponentially higher than that of an enterprise. And for that reason, it's actually a source of inspiration for us at Cinchy. The secret behind the brain's ability is something called structural plasticity. The fact that the brain is rewired when you learn something new. In the enterprise, we try to do this, but the rigidity of the architecture makes this incredibly difficult and brittle. This isn't because of the volume of data either. The brain actually manages more data than the biggest company on earth. It just comes down to the design. It enables evolution. Our brain is designed to accept that there will be change. How many of your organizations have tried to build out an enterprise data warehouse where you've created a model for the entire business? That approach is not organic, and it's a point-in-time representation. It assumes that you know everything there is to know, when the reality is that's simply not the case, because your business is not fixed, it's constantly changing. And an interesting fact, the better organized the information in your brain is, that actually directly correlates with IQ. A data fabric actually provides the foundation to achieve structural plasticity. So what is a data fabric? Well, if you're familiar with data virtualization, it's providing the illusion of a common semantic model with a common access layer over your data. But the data continues to remain in fragmented data silos behind the scenes. A data fabric gives you that same capability, but without the illusion. It makes that real. So data is directly managed within the fabric. At Cinchy, we've adopted our own technology and use our data fabric as the foundation for managing all of our data. What you see here is a representation of our fabric from 2 years ago. Looks quite simple, right? Well, just like the brain, our network of data is constantly evolving. In fact, it changes every day. And because of its plasticity, that doesn't break things for us, but rather yields an incredible level of agility. Sound too good to be true? Well, here's what it looks like. Here's what it looked like last week. There's many more connections, many more nodes. Now you must be wondering what all of these nodes and edges represent. So let me show you a live view of this. So here I've switched over into Cinchy, the platform. And what you're seeing is our instance of Cinchy, the one that we use to power our business. And this is my view into our data fabric. So it's everything that I have access to. Each node here, each circle, represents a data set. Think of that as a table with rows and columns of information. The edges, the lines in between them, represent links, so relationships that exist between these different data sets. As I zoom in, you can actually start to see the different names of things. So this big yellow sun here is our employees. Our employees is sort of the center of our universe in our fabric, and it has the most connections. That's why it's represented here as the largest node. As I zoom in, we can actually see how you can traverse from the employees data set to other information, like transitioning from one domain, the HR domain of information, into another. So employees is connected in turn to the support domain, where you start to see information like different accounts that exist, or even relationships that exist between the employees and which of them are account directors and what are the accounts that they in turn manage inside of the revenue domain. And so you have on the left-hand side here all of the different domains of information that exist. So HR as an example, now I can see all of the related entities within that particular domain and how they're interconnected. But you'll notice that the connections are not only to nodes within the domain, but they do cross boundaries. And these boundaries are typically where you would have otherwise crossed boundaries between applications. Because even within the HR domain, maybe your organization has multiple applications, but here all of the data is represented in one interconnected view. Key difference, of course, in how the human brain works versus an organization is that a brain belongs to one person, whereas an organization is made up of potentially many thousands of employees and systems. In a group setting, there's really two forms of intelligence. The first is this concept of collective intelligence. Think of that as the hive mind concept, which you see in science fiction, like the Borg in Star Trek. The data plus the logic is centralized, and everything connected to it is simply an agent. The alternative is this concept of collaborative intelligence. Here, the agents remain autonomous, and they contribute to a problem-solving network. This is actually the pattern that a data fabric enables. The key difference between the two being control, and the collaboration pattern is far more effective because it maintains the control at the autonomous agent level that is interacting with that fabric. And we've of course seen collaboration in all aspects of the enterprise be incredibly successful. It's transformed how we manage documents. It's changed how we communicate with one another, both in the form of messaging and meetings. It's transformed how we manage our projects. And now it's really introducing this concept of collaborative intelligence. Just like in Star Trek, collaborative intelligence will always win over collective intelligence. All right, so that's a lot of theory and talk about the brain, but what does it mean in practice? How can it impact what you do on a day-to-day basis? So I know I've gone through a bit of this fairly quickly. Now I want you to bear with me. I'm going to spend a fair bit of time on this slide to set the context as I take you through the details. So when you think about how you architect applications today, and you look underneath the hood and you peel back the different layers of it, every application that has been built, whether it's a purchased application that you've brought into the organization and integrated, or it's one that you've created custom, tends to have these various layers. So you have the interfaces, both the UI and API, so the human and programmatic interfaces. You have the logic, the controls that protect access to the data. which is persisted specific to this application. So the app itself has its own persistence layer. You have this gap here, which I'll talk about in a moment, but then you have the integration layer, which is the implementation of the capability of connecting into other systems. And that's typically not done in just a completely generic way when you're building any one application. It's typically architected in such a way that your integration is designed to connect into specific systems, essentially a point-to-point type model. What's missing, however, in this is the capability of plasticity. So when you think about how the brain is operating, it's constantly evolving, it's constantly changing as you learn new information. Here, as the business evolves, this structure is actually incredibly rigid in how you manage information and how the applications need to evolve. If two different applications talk to one another, so let's say you have team A that has produced system A and team B has system B, and they're sharing now information with one another, there's typically a contract that is established. And that contract is quite rigid. It forms the assumption for team B to now consume that data. And if team A now wants to go and make a change to system A as a result of new requirements in the business, which would evolve how they internally manage their data, then one of two things need to happen. Either they need to drift their implementation from that contract and continue to remain compatible with the contract itself, so that now they have this gap that over time will continue to grow. Or alternatively, you have a situation where now they need to coordinate that change with team B as well. So this is where the bottleneck comes from in integration. It's that coordination exercise as well as the change management problem that you run into when you have integration implemented in this manner where there is no plasticity. And so that causes a tremendous amount of challenges when you're trying to modify any one solution inside the organization, because typically no one solution is a complete silo, and it will have consumers of information that it produces. So a simple example of that would be trying to rename an attribute. And if you think about what constitutes a breaking change that would have a direct consequence to consumers of your data, there's many different situations, but a rename is probably like the simplest one to think about. And in that situation, if one is trying to rename how they represent a particular attribute, they simply can't do that without either, again, coordinating with the consumer of that information to try to have the changes take place at the same point in time, or just having it be represented differently in the contract that they make available for those consumers. So that's the challenge, and that's what this gap is really representing, is that there's no abstraction layer giving you any sort of protection from that. There's no capability there. Now, when you look at that contrasted with how this would work in a situation where you have a data fabric, well, the data fabric itself, firstly, cuts across different systems. And so it provides you the capability of connecting different systems together and allowing them to collaborate on information, which is persisted in a fabric, in essentially a centralized location. And that now eliminates the fragmentation problem, of course, that you have, but it provides that capability of collaboration across, and you don't need to implement sort of point-to-point integration solutions. The layer above that now is this capability of structural plasticity that can be built once you have that foundational data fabric in place. And so the structural plasticity gives you an abstraction layer that can protect and insulate you from essentially schema evolution. So as systems are looking to make changes, if we take that same example of team A making a change to system A, looking to simply rename an attribute, the plasticity layer actually protects team B from that change. It becomes an automatic thing where you don't need to go and start to drift your implementation. Instead, it manages everything, in this case, by reference, in order to ensure that nothing is actually broken, no pointers are broken or impacted. And there's other situations as well, whether an attribute is deleted, whether other types of breaking changes take place. And in all such situations, this concept of structural plasticity, or this capability rather, is able to deliver that missing gap. Above that, we have application augmentation. So building solutions in, or connecting, solutions together inside of an environment where you have a data fabric in place. You would take advantage of the structural plasticity in the data fabric to avoid doing integration work between any two solutions, any two systems that you have. And so that's this concept of application augmentation. Then you have this concept of autonomous data, where with this first layer here, you're eliminating the need to do integration. What autonomous data is doing is it's eliminating the need for you to implement controls and persistence specific to your one application. And all that remains is the UI, the API, and the logic. So you're getting the controls and persistence as a service through the capability that the collaborative intelligence platform, so that being the purple boxes, built, of course, on top of the fabric, is providing. And then an additional layer that adds on top of the autonomous data is this concept of a metadata experience. So this capability here, what it does is when you think about a UI or an API, these interfaces, based on the metadata that is managed inside of the autonomous data layer, inside of the data fabric, it's able to generate a dynamic interface for you. And that's true both for a human interface as well as for APIs. So when you think about delivering solutions now in a world where you have a data fabric in place, one that has the capability of delivering collaborative intelligence, what you end up doing is, for enhancements to applications, you can go about augmenting your existing apps and using the fabric in order to bridge the gap between different systems for the purposes of enabling them to collaborate on data. And for net new solutions that you want to stand up, you have the ability to create a much thinner slice of what you otherwise would have produced in the form of an application experience. And this application experience only concentrates on the specific business outcome that you're trying to deliver. What does the UI look like? What does the API look like to support that? And any logic that goes along with it. Everything else becomes a service and provided through configuration. So that is a dramatic simplification. And in addition to that, even the work that you would do on these three components is further reduced by the metadata experience, because the metadata experience now can take on some of the effort by providing those capabilities in a dynamic manner. So when you think about current state architecture, again, the fact that it is incredibly rigid, it really is aligned with this diagram on the left-hand side. You have existing applications, you potentially have microservices inside your organization. Maybe you have employed some sort of machine learning-based solution, and then you have net new solutions that you're going to stand up in the future. We have two levels of integration that we do between these different systems. The first is the application integration layer. And that you can think of as facilitating the reuse of code, where applications have built logic, they've built functionality, and here you're taking the opportunity to actually reuse that by invoking an API that exists and is exposed by one application, rather than rebuilding that logic and replicating that same code inside of your system. So there's, of course, tremendous value to doing that and taking that approach. But at the same time, we also have this spaghetti in between, which is the movement and flow of data between these different systems. And this flow of data, it's facilitated by a number of different patterns. You sometimes see ETLs, you'll see even API invocations, where the caller or the calling system takes the data and persists it localized inside of their own app-specific database. Or maybe there's a broker system in between, like a message broker that's able to pass events but the end result again is that data is being copied. And so that's what this left-hand side is all about. So regardless of how you structure the middle, at the end of the day, these become point-to-point connections because you end up creating replicas of data. Now, contrasting that to the plasticity model, by introducing a data fabric in the center here, we have a fabric that has this capability of collaborative intelligence layered on top of it. So it's giving you the structural plasticity, it's giving you the autonomous data management, and it is giving you the metadata experience. And in this ecosystem, if you wanted to connect different data, different systems together such that they could collaborate on data, you connect that system to the fabric, and now the other systems are able to, subject to them being provisioned access to that data, able to collaborate on that information, whether it's for accessing it, whether it's for going in and updating that. And so the fact that now you have this fabric, which has a substantial more amount of data and information than any one system does, allows you to now begin to augment the capabilities of an existing system. And so it is all of a sudden smarter the moment it is connected to the data fabric because it has access to all of this data that it otherwise would not have had. And for net new solutions that you stand up, new app experiences, you do so without provisioning that database, and those manage their data data directly inside of the fabric, taking advantage of the autonomous data concept. So going a little bit deeper into this capability of application augmentation, like what does that really mean? Well, when you think about the options that you have when you're dealing with a legacy system, so a system that you may have internally within your organization, you can either continue to maintain that system, or you can rebuild that system. So maintaining it is typically challenging because you'd like to add net new functionality, to add new capabilities, and that is an expensive exercise. Alternatively, if you go to rebuild it, that also is incredibly expensive because now you have to, there's risk associated with it. There's also, of course, the cost to go and rebuild that, redesign and re-architect it such that based on your current understanding of where the business is headed, you can try to make it a bit more strategic, but you'll eventually end up in a state where that becomes legacy again. Alternatively, you can augment the application. And so augmenting it is the concept of building out an extension without necessarily disrupting what's already there, or with minimal change to what's already there. And augmented applications are structured in a way where they're connected to the fabric to make them more intelligent. So if we look at a hypothetical project, so inside your organization, as you look at your IT projects, they're typically either enhancing existing systems or standing up net new. So if we think about enhancing an existing system, and we start with that scenario, then when you look at, again, the same stack of the systems that you have these various layers, UI, API, logic, controls, and persistence. The enhancements would typically be implemented in each one of these layers. So if the nature of my project was one where I needed to manage net new data and I needed to, I would add that into my persistence layer, implement my controls around it, I'd create logic to be able to interact with that. My API and UIs would need to adapt as well in order to deal with this new capability and either expose it to users and or systems. And so what happens with the application augmentation approach is that you reduce the scope of change to this legacy application. And instead, you push as much as you can down to the fabric itself. And so what's happening here is that controls and persistence are actually managed. Let's see if I can get a pointer. Okay, so here in the application augmentation, the controls and persistence are empty here because the implementation is actually done within the fabric. But the UI, API, and logic, so the logic layer directly connects into the fabric. It's able to interact with the data that exists there through APIs in order to make it a seamless experience as if that data was localized. And for any dependencies that exist, the data inside of this one application can also actually be made available inside of the fabric, such that relationships and dependencies can be resolved, so that there's common identifiers, there are common data sets that are accessible, so that for this logic layer, when it is accessing the fabric, it doesn't need to go and necessarily bridge the gap between data that it already has versus what's in the fabric. And of course, if you have any additional dependencies on data that lives elsewhere inside of your organization, you have the ability to connect that into the fabric as well, and to bridge that gap, and again, connect it and bridge, establish the relationships with this new data that you're generating directly on the fabric. So the red here is representing autonomous data. For that information, you of course have the capability of taking advantage of the metadata experience in order to further reduce any of the work that you're doing, depending on how it's to be used in the context of your project. And so that's the paradigm of application augmentation. When it comes to now new system development, if you're standing up a net new solution, then again, persistence and controls goes away, because you take advantage of the fabric's capabilities to deliver that as a service, done through configuration, and instead you concentrate on just the UI, API, and logic portions. And here too, you would still rely on the metadata experience to provide the capabilities where it can, and minimize the work effort involved in your low code or pro code type implementation. Well, that was a lot to cover, and I realize there's a lot to learn in this space. You can come to cinchy.com/learn to learn more. We do run a weekly session because there are so many new concepts in this area. And if you do have any questions, please feel free to directly reach out. On the cinchy.com/learn page, there is a section where you can book a session as well to go deeper. Thank you.
All right, so we're back. So that was great. So that's Karanjot, the CTO of Cinchy. And back with me, we have Tyson Rose. He's the solution architect and sales engineering over at Cinchy. So a couple Q&A questions. So as part of this data collaboration, right, rather than collective side of it, can maybe speak to some of the risk associated with it, Tyson?
Yeah, I mean, there's always going to be a level of risk when implementing a new technologies like a data fabric. And what I'd say is the risk is if you go with the big bang, if you try to bring all of your data into a data fabric and try to do it all in one go, there's always going to be an associated risk with that. But what we do is, and we've been successful at encouraging our clients to start with a particular project or a use case and leverage that use case to pay it forward. Leverage that use case to continue to grow your fabric. And naturally, over time, your fabric will grow. And you start to deleverage the risk as you start to incrementally grow your data fabric. But inherently, the natural risk with any type of technology like this is always going to be if you're trying to try to do everything all at once. And it's something that we've always encouraged our clients not to do.
Okay, so a little bit more incrementally rather than this kind of like end-to-end approach or ingestion at one time.
Exactly.
Right. And so maybe along those lines, if you think in the context of a use case for adjacent industries, why might a company choose this type of technology or this type of method over another?
Yeah, I'd say a common use case that we see is a client 360. You have a client 360 program. You have many different touch points around how you interface with your client. And there's a chance that there's many different integration layers that are involved in trying to do that. And where our clients are seeing a lot of value in that particular use case, and there's many more use cases that are very similar, but I'm just using that as an example, is that you can start with one or two specific touch points. Maybe it's your transactions, and maybe it's your service desk, and you want to build a solution around unifying all of that information so that your service desk has details about transactions. And that's the starting point, and that's where you can get, your fabric up and running. And from there, you incrementally grow it, and you start to add more components to your Advisor 360 program or your Client 360 program. And again, when you think of other use cases, that's how you incrementally grow it. You start it with a use case, you build that solution on the platform, and then you continue to build solutions on top of that fabric that leverage what you've done existing on the platform. And that's what we're seeing. It's a very common theme. It's universal across industries. So there's no one particular industry that's using it in a different way than another. You're seeing a lot of commonalities in terms of how they're building and growing their platforms. And it's just it's something that we encourage as well in terms of how you kind of scale and grow your platform experience.
All right, great. Real quick, closing up here. Are you aware with in terms of the tooling itself, does it provide the ability to use other connectors from the visualization side into Cinchy?
Yes, so we do have some out-of-box connectors for data visualization tools. A lot of business intelligence analysts are leveraging our platform for aggregating data across the enterprise, and then you're using our no-code APIs to either publish the data directly to a specific data visualization tool, but then there's the out-of-box ones like the Power BIs, the Clicks, that essentially once you get your Cinchy up and running and you have your data in there and you know what type of data you want to analyze in your visualization tool, it's literally a plug and play. And we have several of them out of box. And then there's the capabilities of building your own visualization tool and then connecting through our REST APIs.
Great. And last question here. So could you talk about either users or industries that may be using it in production?
Yeah, so we've been fortunate in terms of some of the largest financial institutions in the country are leveraging our platform in production capacities. As I mentioned earlier, the Client 360 is a common use case in financial services. We've been successful. One of our recent wins was the YMCA. We've been doing a lot of really interesting work with them to help them with the process of getting their members into their facilities in a safer way, leveraging our technology in this post-COVID world. We're working with insurance companies. Most recently, an internet service provider is leveraging our technology. So we're agnostic to industry, and we're capable of leveraging our platform in multiple different verticals or industries. And that's the reason why we're seeing the success that we're seeing is because we have the capability to work across industry. But financial services obviously is the bread and butter of what we do because a lot of our domain expertise comes from there, and we've been successful with some of the larger Canadian banks and asset managers, wealth management companies as well.
Great. Thanks a lot, Tyson. I think we're wrapping up here. We're out of time now. But awesome. Thanks for your time.
Yeah, thanks a lot.
All right.